Shamant. Shall I start? Are you able to see the screen and anyone unmute yourself and tell me the screen is visible and audible?
Yes, sir.
Okay. The last class we discussed about the definitions of few factors, few words which are very essential for mechanical measurement. That is calibration. Calibration is nothing but the comparison of unknown magnitude, known magnitude, standard known magnitude used in the machine shop or workshop or in the industry that is calibrated by comparing the standard, measuring the same standard instruments available in the standard institution. That is called calibration. In the same way, whichever the instruments we use in a machine shop or a workshop or anywhere in the manufacturing industry, that should be calibrated in a year or 2 years once. You have to calibrate with the standard organization. Might have seen near to the court circle in the Balrajar Sir Road, there be a institution is there, Department of Weights and Measurement. Suppose if you are dealing with the public for measurement, suppose if you have the petrol bunk, grocery shop, or any shop where you deal with the measurement. Say, for example, if you are giving some material 1 kg, 2 kg, 3 kg, like that to the public, that instrument, measuring instrument should be calibrated once in a year or 2 years once. So that should be mandatory. That's made by Government of India. So that is the calibration. Next, come to the point, sensitivity. The sensitivity of the instrument is very, very important. Say, if you provide input, for that you must get the output. So if you plot the graph, input versus output, you will get the slope like this. So that is calibration curve. So this indicates the how much sensitive you are measuring instrument. That is very, very important. That is limit to delta tends to zero. That is the meaning of this word. This relationship is for zero value, you must get zero. Suppose if you provide one, for that you must get one. But in actual practice, you will get 0.999 or 1.01. So if it is the higher value, then it is the error. That is the positive error or negative error. So like this, the sensitivity of the instrument can be defined like this. Limit delta tends to 0, dQo divided by dQi. That's the meaning of this relationship is for any input, you must get output. That is the sensitivity. Next comes the point, repeatability. So I told you uh, measurement of oil at morning to evening. See, ask you to measure the temperature of the oil which you keep in the laboratory from morning 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, and 2 o'clock, 3 o'clock, 4 o'clock, and 5 o'clock. See, at 10 o'clock, you have 32 degrees centigrade. At 12 o'clock, you have 33. 1 o'clock, you have 34. 3 o'clock, you have 35. Again, 5 o'clock, you have 32. Why? The system is same. The temperature measuring instrument, thermometer is same, oil is same, everything same. But the answer, result of the measurement is different. So that is called repeatability. Difference in the measurement result. That is repeatability error. If you repeat the experiment, repeat the system, you must get the same answer or the same result. Type of error you have to avoid or remove. So for that, what you have to take the average of the results. So you have, say, for example, you have 7 results. Divided all the results, you sum the all the results, add the all the results, divided by 7. That will give you the answer. Like this, you can remove the repeatability error in the measurement. Next, come to the point, hysteresis. So all of you seen the utensils which we are using in the kitchen. See, the aluminum, copper, stainless steel, bronze utensils. The shape of the tumbler, the shape of the container. So that you can provide in Kannada we call it as koda and hande. So those things are manufactured by the using the concept hysteresis. Alternatively, loading of the specimen in tension and compression. So there the deformation takes place. In the elastic limit, the deformation is reversible. In the elastic limit, the deformation is reversible. So after the elastic limit, there may be deformation that is irreversible. That concept is very much essential for manufacturing of utensils. So that is nothing but hysteresis or threshold resolution. Next, come to the point accuracy. There will be two types of accuracy. One is the full scale accuracy and the reading accuracy. So we can use this relationship for calculating accuracy of the instrument. Next, come to the point precision. For this good example is the clock show. All of you seen clock show. Suppose if you set the clock for 9:20, 9 o'clock 20 minutes. So the 9:20 is accurate when in the morning and in the night. So this is precise when 2 hours. That is in the 24 hours. This reading 9:20, which is precise. See, we can define like this. The precise can be defined as the measurement with a small random error. Measurement with a small random error. Next, come to the point. New topic. Transducer. Transducer. Say, for example, if you want to measure the resistance of the system of the circuit, or very good example is the speedometer in your two-wheeler or four-wheeler. In the dashboard, you have electronic speedometer or digital speedometer, which indicates the speed of the vehicle in terms of kilometer per hour. So the transducer is nothing but detector, primary detector, which detects the primary signal and amplifies the signal and convert that signal into analogous signal. Again, that analogous signal is converted into voltage signal. Then voltage signal is converted into digital signal. You have the result of the measurement in terms of kilometer per hour. That is nothing but the rotation of the wheel is converted into the rotation of the cable, flexible cable. The flexible is connected to the meter where you have the transducer which transduces the rotation of the flexible cable into voltage signal or analogous signal. That analogous signal is converted into voltage signal. Again, that voltage signal is converted into digital signal. That digital signal is converted into or displayed in the digital display that is in kilometer per hour. So this is the electronic display of speed of the vehicle. One more example, the dial indicator which we use in the metrology lab for the measurement of taper angle or measurement of thickness of the component. Two is there also the plunger moves in the upward direction. Due to that movement, there will be rapid pinion arrangement is there. The dial of the pointer rotates 1,000 times or 10,000 times. So that is the reading. That is the transducer. The rack and pinion is rack and pinion is rack and pinion arrangement is there. That is nothing but transducer. Transfer efficiency. In the transducer, first you have to study the transfer efficiency. That is nothing but the performance characteristics of the system. That may be engine, maybe motor, or that may be the pump, or that may be the turbo. So whether All of you just go through the relationship for transfer efficiency. The input to the system is I in, the transduced, that is the output from the system, is I out. Input to the system is I in, and the transduced form is I out. That can be related in the following relationship: I out equal to F of I in, and the transfer efficiency equal to I out divided by I in, which is less than 1 or less than unity, which is less than unity. See, in all systems, for example, electronic system or diesel engine or petrol engine or air compressor or turbine or any instrument, for example, motor. Same. If consider the diesel engine. What is the input? Input is the diesel. So in that engine runs at the higher speed of 1100 or 1200 RPM. See, the performance of the engine is 100%? No. Then, if the performance of the engine is 100%, then transfer efficiency will be 1. See, you will not get 100% efficiency in diesel engine or petrol engine or any system, whether it may be turbine, whether it may be air compressor or anything. You will not get 100% efficient. Maybe 80% or 60% or 70%. So always the transfer efficiency is less than 1. That is, you can define the transfer efficiency like this: I out divided by I in. I in is the input to the diesel engine, and the output of the diesel engine is I out, always less than 1. Say, in the actual practice, you will not get 100% efficiency, 100% efficiency, which is always less than 100%. That is nothing but 1, less than 1. So that can relate like this: transfer efficiency equal to I out divided by I in, which is less than 1. The transfer efficiency can be defined as the ratio of I out to the I in, which is always less than unity. See, all of you, please write down the question. Please write down the question. What is transducer? What is transducer? Put a question. What is transducer? Put a question mark. Explain briefly. Explain briefly the transfer efficiency. So for transducer, you have an explanation here which converts the input signal into the analog signal. Again, that analog signal is converted into voltage signal. Again, that voltage signal is converted into digital signal. That digital signal can be converted into the display, that may be resistance, that may be speed of the engine, speed of the vehicle, anything. So this is the prime transducer, also called as detector inter, which is called as detector transducer. Next, for efficiency, explain briefly the transfer efficiency. The transfer efficiency can be defined as input to the system is IN and output of the system is I out. Transfer efficiency equal to I out divided by I in, which is always less than 100% or unity or 1. So this is very, very important. You can expect this question in the examination. Please all of you write down, very, very important. Next come to the point. Transducers are classified into primary transducer and secondary transducer. The primary transducer transducer and the secondary transducer. You can explain the primary transducer or secondary transducer, which is very much essential measurement purpose. So that is the input to the system, input to the engine, or input to the air compressor, or input to the turbine that receives the input signal, and primary transducer is called primary transducer receives the input and convert that input into the form which is accepted by the secondary transducer. See, all of you observe here in the block diagram. This is the input primary transducer. So that is instruments on analogous form. In the primary transducer, which receives the signal from the input, converting it into the analogous signal, and this analogous signal is fed to the secondary transducer. This secondary transducer converts the primary signal or analogous signal into voltage signal or the form that can be read by the human being. The secondary transducer converts the analogous signal into voltage signal. That voltage signal is converted into digital form. In the digital display, the operator can read the output in the form of which is required, whether it may be resistance, then it is in ohms. If it is speed, that is in kilometer per hour. If it is pressure, that is kg per millimeter square or in bars. So once again, that the transducers are classified into two types, primary transducer and secondary transducer. So these two transducers are very much essential for all the measurement, pressure, temperature, force, or anything. That is primary and secondary transducers are very, very important. Next, come to the point that we can explain the primary transducer and the secondary transducer by using block diagram. First, write the block diagram, show the input to the primary transducer, and then show the output from the primary transducer, which is fed to the secondary transducer. In the secondary transducer, the signal coming from the primary transducer, which is in analogous form, which is converted into voltage signal, and again that voltage converted into digital form or a digital signal, then that digital signal is displayed in the digital output, whether if it is pressure that is in kg per millimeter square or bar, whether it is the resistance, then it is in ohms, whether it is speed of the vehicle that's in kilometer per hour. So like this, you can explain the transducer, the classification of transducer. Please, all of you, write down the question. Explain briefly. Explain briefly with the block diagram. Explain briefly with the block diagram the primary and the secondary transducers. Primary and secondary transducers. Primary and secondary transducer. And you can explain the primary and secondary transducer using this block diagram. Once again, the input to the primary transducer, whether the primary transducer receives the input, convert that input into analogous form, then the analogous form is fed to the secondary transducer, where that analogous form or analogous signal is converted into voltage signal. Then that voltage signal is converted into digital signal, and that digital signal is displayed in the digital display board. If it is in temperature, that is in degree centigrade, whether it is pressure, that is in kg per millimeter square, or bar. If it is resistance, that indicates the resistance in ohms. If it is the speed of the vehicle, that is in kg per, that's in kilometer per hour.
So like this, the display that can be used by the operator or the person who operate the primary transducer and the secondary transducer. The input to the primary transducer is amplified, which converts the input into the voltage signal, put into the analogous signal. Again, that analogous signal is fed to the secondary transducer, where that analogous signal is converted into voltage signal, then that voltage signal is converted into digital signal or digital form that you can directly read from the digital display board. So like this, the primary transducer and the secondary transducers are very, very important for mechanical measurement. All of you, please write down the question, explain briefly with the block diagram, primary and secondary transducers. Transducers are classified. The transducers are classified into electrical transducer, electronic transducer, mechanical transducer, and different types of transducers. See, all of you observe here. The In the explanation, we have electronic transducer, the mechanical transducer. A good example is dial indicator in the module 2. While explaining the comparator, the measurement of taper, we use the dial indicator. The mechanical transducer means dial indicator. And again, LVDT. See, we studied the linear variable differential transformer in comparator. So in comparator. So this is also very, very important. So this is used in machine tools in lathe, milling machine, grinding machine. So reversing of the table, which is carried out by using LVDT or linear variable differential transformer. See, you have this experiment in the metrology laboratory. You understand how to use LVDT for measurement. So you understand while conducting the experiment in the metrology lab. So if it is possible, you have to conduct the experiment in the metrology lab. Otherwise, I will explain the LVDT here or later. So this is very, very important for mechanical engineers. Electrical transducer means linear variable transducer, that in form, in small short form, it is called as LVDT. See, all of you seen in the lathe the carriage movement from headstock to the tile stock to the headstock. That is the conversion of movement of the carriage after reaching the extreme position in the tile stock side or in the headstock side. The changing of position of the carriage movement, which is carried out by the linear variable differential transformer. So this is very, very important for measurement. Say the good example is grinding machine. In that the table moves forward and backward direction. In the same way, while thread cutting in the lathe, the carriage moves forward and backward direction. There you need the LVDT, linear voltage differential transformer. This is a good example for electrical transducer. And the good example for mechanical transducer is a dial indicator. We use the dial indicator for measurement of taper of the component in metrology lab.
Next, come to the point, very, very important. Please, all of you, write down the question. Explain briefly. Need sketch. With need sketch, mechanical transducer. Mechanical transducer. Put a question mark. List, list applications, applications and limitations. List applications and limitations. Write down next question. Explain briefly with the need sketch. Explain briefly with need sketch. Electrical transducer. Electrical transducer. In bracket write down. In bracket write down. Linear, linear, variable, differential, transformer. Is not transducer, it is transformer. Linear, variable, differential, transformer. Put a bracket, again put a round bracket or circular bracket. In that mention LVDT. 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 Next come to the point. Electronic transducer. Electronic transducer. All of you, please write down the question. Explain briefly. Explain briefly. It needs sketch. Explain briefly. It needs sketch. The electronic transducer. The electronic transducer. The electronic transducer. Put a question mark. Next, you write down list applications. List applications and limitation. List applications and limitations. See, in the examination, you may have a question electronic transducer, electrical transducer, mechanical transducer. Among three, one is 100% guaranteed in the examination. Remember, among three, one is 100% guaranteed examination. Please, all of you, very, very important. Electronic transducer or electrical transducer or mechanical transducer. Mechanical transducer. So what are the things present in mechanical? What are the things present in electronic transducer? This is the plunger. This is the plunger, and which is moved up and down. See the arrow mark observed here. There will be displacement in upward as well as in downward direction, which is directly connected to the flexible diaphragm. Flexible diaphragm. All of you seen the speaker, in the center of the magnet is connected to the electrical diaphragm. All of you seen the same type of diaphragm made of PVC material, which is used in electronic transducer. Again, the same plunger of which is the deformation or deflection coming from the diaphragm, which is connected to the tungsten coil, tungsten wire coil. This tungsten wire coil is connected to the two plates, which deflects two plates made of silver alloy or copper alloy connected to a tungsten coil. See, this displacement of the plunger, which is makes the blades to move up and down. There will be one more rod is present, which is connected to the terminals of the millivoltmeter or milliammeter. This electron transducer very much used in measurement of the surface roughness of the face plate or granite slab. So all of you seen the granite which are finished up to mirror finish, which are surface is finished up to mirror finish. So if you touch with the bare fingers on the granite surface or surface plate, you feel some waviness present on the surface of the surface plate, which is manufactured from cast iron or the granite slabs, which we use in metrology lab as well as in machine shop and also in the workshop for marking of the specimen or marking of work pieces, we use the surface plate. The surface plate is finished, looks like a mirror. So that honing operation or lapping operation by finishing on the surface, they provide the mirror type of finish on the surface. If you touch with your bare fingers, you feel some waviness is present on the surface. That roughness of the surface that can be measured by using electronic transducer. See, this plunger or displacement of the plunger is amplified by the flexible diaphragm, which makes this plunger to deflect up and down. This plunger is connected to the tungsten coil. Again, this tungsten coil has two silver plates or copper alloy plates which deflects. Due to that deflection, there will be change in the electrical characteristics. Remember the electrical characteristics, the deflection of the plates. There may be change in the electrical characteristics that can be measured by using the terminals which is connected to milliammeter or millivoltmeter. Say before conducting the testing of roughness of the surface plate, bring the millivoltmeter or milliammeter to read zero, then move this plunger which displays from original position to the upward direction or downward direction. That deflects. That deflection is amplified through the flexible diaphragm. The flexible diaphragm is connected to the coil made of tungsten. Again, this coil is has two plates which is made of silver alloy or alloy which deflects. Deflection of these two plates, there will be change in electrical characteristics that can be measured in the terminal which is connected to millivoltmeter or milliammeter. So this is very very important. Please all of you mark very very important. Among three, one is 100% guarantee in the examination. Please, all of you, write your name and USN in the chat. Today, this much is enough for you, and I will continue in the next class. Now, I stop at this stage. Please, all of you, write your name and USN in the
Answer your roll call. Call you the name, all of you. Unmute yourself. All of you unmute yourself. I will call the name. Unmute yourself. I will call the name one by one. I have the attendance register in my hand. I will call the name. All of you, please unmute yourself. I will call your name. Unmute yourself. Gavish. Gavish. VM. Amant, yes. Vinayak Adriali. Vinayak N. Vinayak N. Yashwant KR.
Yes, sir.
Nitin GS.
Yes, sir.
Nitin GS.
Yes, sir.
Nitin LM. Pawan H. Pawan H. Pawan Kumar GV. Pawan Kumar GV. Pawan MC. Pawan T. Prajwal Chaudhary. Unmute yourself, all of you. Pratham P. Pratik R. Basanagowda. Pritham D.
Present, sir.
Raghavendra E. Rahul MP.
Present, sir.
Rahul N. Rajat GC. Rakshit GL. Rakshit R. Ranjan Kumar. Renil. Renil. Renil H. Gowda. Ritik M. Ritik M. Mohammed Iftekhar. Mohammed Iftekhar. Salik Ulakan. Sambram. Sanjay K. Shashank KB. Shashank HS. Siddharth.
Present, sir.
Subodh. ಯಾರು ಹೇಳಿ
Siddharth.
ನಿಮ್ಮ ಹೆಸರು ಹೇಳಿ
Siddharth, sir. Siddharth.
ಸಿದ್ಧಾರ್ಥ್ ಓಕೆ ಓಕೆ ಪ್ರೆಸೆಂಟ್ ಸುಬೋಧ್ ಸುದೀಪ್ ಸುದೀಪ್ MD ಸುಹಾಸ್ P
Present, sir.
ಸುಮುಖ್ ರಾಜ್ ಸ್ವರೂಪ್ ಗೌಡ ಸ್ವಾತಿ ಸೈಯದ್ ಮೆಹತಾಬ್ ವೇದಶ್ರೀ ವೇದವ್ಯಾಸ್ Vinith, Vinay Patil, Yashwant S, Karthik BG. Please, all of you, inform your friends that next class onwards, I will take the personal attendance as well as in the software, Google software. Please inform your friends. I will inform them through message also. I will take the attendance after completion of the class. Please tell your friends or put the message for them that they have to be present complete class. Otherwise, treated as absent. Okay. Now, stop at this stage. I will continue in the next class.